Okay, we're going to talk a little bit about a relay, and so here's an example of a relay right here that you see on your training board. And there's a lot of other different varieties of relays that we're going to look at here. But what is a relay? So let's just get to the bottom of it. The relay is an electromechanical switch. Okay, and so what that means is that you're going to have a coil. Okay, and when you give the voltage to that coil, it is going to create a magnetic field. Okay. And then so on this side, what you're going to do is you're going to have a switch that's going to shut because there's going to be some type of a plunger here or something that gets pulled towards the magnetic field. And then when this shuts, then this side, which is a switch, will then conduct electricity. Okay, so you might consider this as an output. You would hook this up as an output in your control circuit. And on this side, you would be connecting this as an input, and you would be showing it as a set of contacts like this, right? And this over here would be getting shown as a coil like this, where you might have one CR and one CR, okay? So let's take a little bit of a better look at it. So what I have right here, I'm going to bring in my multimeter, and I'm going to bring in a relay right here, okay? So this is a relay, and this middle part moves up and down right here, okay? And so I can push this, I've got this set for continuity, and I can push this by myself like this, and notice I get tone. What have I done? Well, I've hooked my multimeter across the set of contacts here. I've got 1, 2, 3, 4 sets of contacts here, okay? I just picked one, okay? And when I push this button, I get continuity. It's closing the switch between there. So this contactor, by the way, has 1, 2, 3 for your three-phase power, and then it would have another set of contacts for your memory. That's typically how these work. But I am acting as the actuation here, but almost like a push button. But a relay is set up so that it works by being automatic by voltage. So if I switch on the voltage here, watch what happens. You notice that closes, and I get tone. When I release the voltage, it comes off, okay? So that is what this relay is. It's an electromechanical switch. It's not like a push button where I just push it down. It is made to be actuated by a magnetic field, okay? So I'm going to go ahead and pull this out of here because we're going to look at this one again in a minute. So there's a lot of different types of relays. So in the simplest sense, you might have just a basic control relay right here, okay? So this would be a control relay, sometimes referred to as an ice cube relay, okay? And it would come on a base. This base right here is made to be mounted on DIN rail, so it would just click in, and then you could put the module, right in like that, and it would click in, okay? And then this item here is the relay. Now, this is your basic relay. What you would want to do is you need to know a couple things about a relay. You need to know the voltage that it's rated for on the input on the coil side, because you want to burn it out. And then you would want to know the current that it's rated for the contacts. What are you switching? Okay. So if you hook this up, you want to be sure it's the right voltage, and then you don't want to pass too much current through it because you're going to burn it out. So a control relay is a little bit smaller, and it's not going to switch as much current. But if I look at this, you'll have to look around a little bit. But if I look on this one right here, I see where it says AC 12 volts there. Okay, AC 12 volts is what this is reading. And that is the coil here. So if I ran 12 VAC to this right here, that would create a magnetic field, and that this would switch, okay? So the other thing that you have to do is you would take a look at the diagrams here and try and figure out what's going on. This one is a 7 amp relay, okay? So I see 1, 2 poles in here. I see these contacts here. And so if I look to the side, one's closed, and then it clicks over, and that one opens, and then this one closes, okay? So it's just got a double pole, because it's got one here and one here, and it's got a double throw between this switch and this switch, all right? And it does 7 amps. So you could use this to turn on something through these contacts, but they couldn't be more than 7 amps. So that is a basic control relay, okay? And it's used for a lot of things, logic and holding and stuff like that. Now, the next step up from a control relay is a contactor, okay? So a contactor, what that does is it has allows for more current on the contacts, all right, that when it closes. So a contactor, you're going to be able to turn on something that is larger, okay? So the coil side of the contactor, it's still going to have some, it's going to still be rated for voltage right here, the contactor. And you need to be aware of what that is, but typically it doesn't take very much voltage or current necessarily to turn this contactor on, okay? So you can pass a very small current here, you know, of a different voltage and turn the contactor on, but you can switch a much larger current on the contact side of this. What you're looking at right here, all you need is you just need a little magnetic field, and then this would switch, and then this circuit over here could really pass a lot of current, okay? Because these are separate. So if you look at these, so once again, here's a what's called an IEC style of a contactor, okay? I've got 1, 2, 3, 4 sets of contacts across here, and the A1 and the A2 would be labeled here. This is where my coil goes. So I can see this one here says DC 24 volts. So that is what my coil is here. This is a 24 volt actuation. So I would want to put on this contactor right here 24 VDC, and then it will create a magnetic field, and it'll pull that down and switch. Remember, this one was 12 VAC. That's what causes this one to actuate, okay? So when you get these, you want to be sure that you're getting the right voltage to the coil first. This is one right here. This is another Allen Bradley one right here. This is a contactor. It's got 1, 2, 3, 4 sets of contacts. This one says normally open, normally closed, normally open, normally open. So it's got a different contact arrangement there. Depends on what you want, what you're using it for. And then right here's the coil. It says 24 VDC. So when you're looking for how to turn it on, you got to find the thing that's marked for the coil, 24 VDC. And just like this one right here, it was marked 24 DC 24 on this terminal right here. So you got to be able to identify which one of these terminals is for the voltage, okay? Here was the one that we looked at a second ago, all right? This is a little more of a NEMA style because it's serviceable. So I can open up, I can take these screws off right here and I can open this up and I can service the contacts and stuff in here. Whereas this one right here, this one isn't really serviceable, this IEC, but these styles, this style is. So if I wanted to know what this was, you got to come around and I see right here 24V and it says 60 hertz. So because it's got a frequency on it of 60 hertz, 24 volts, 60 hertz, I know that this is alternating current. So this is a 24 VAC coil. That's what actuates this one right here is 24 VAC. If you put 120 volts onto here and here, well, you're going to burn that up. Okay, just like this one, this is 24 VDC. If you plug in 120 volts, you're going to burn that coil up. Okay, if you want a 120 volt relay, well, you're going to have to get one. Here's another style. You think, well, these two look pretty similar. Yeah, they are pretty similar. The difference is that this one's got a coil that says 120, 50, 60. So this is 120 volts, 50, 60. So that's my coil right there. And that is for 120 volts. That's what's going to cause this to pull down. If I put 24 VDC right here, it's not going to work. Remember, we don't want to blow these coils up, okay? So those are contactors. And then the other item, the next step up, is the motor starter, okay? So as we said, we have a control relay. That's your basic electromechanical switch. A contactor has higher current ratings and possibly more contacts. Okay, this can have a lot of contacts as well, but this is going to be designed to start like a 3-phase load a lot of times. Okay, and then we're going to have a motor starter. So a motor starter is going to be a contactor, but it's going to have a contactor plus an overload on it. Okay. And so what does that look like? Well, here's an overload. This is an overload, and we're going to get into these a little bit. This is sensing we're getting heat. So typically you would take these two, you would take your contactor, and you would kind of marry it to these like this, and that you would have a motor starter. Okay, but you could wire these separately if you wanted, but they sell these where they're just combined together. And so here's an example of what one of those might look like. Okay, so this has got my contactor here. And over here is the overload, and this is this protects it from getting too hot. And basically what they did is they pushed them together. They married them together, and I've still got 1, 2, 3, 4 sets. I got my contacts, and then I've got my coil. And same thing on this one. You'd have to look around. I see my coil right here, and it says 220 VAC. So this coil is going to take 220 VAC. You have to run high voltage to that in order for this to come down. Okay, so here's some examples of different contactors, and they come in a lot of different shapes. I mean, here's another one like this. This is another contactor, and it says it's got an arrow saying up right here. So this actually gets mounted this way because it works with gravity. And so if you come right here, it says that this thing is rated for 30 amps. That means here's my my switch here between here and here and here and here and here. There's 3 switches on here, and they switched 30 amps. Well, that's a lot, because we just said this little one right here, that only switched 7 amps. If you tried to switch 30 amps with this, you would burn it up. The contacts here cannot handle that much. Okay, but this one right here works with gravity and gets mounted up, and it takes 120 volts in order to actuate it. So yeah, these relays or these contactors can come in a variety of different shapes. Now, what are they used for? Well, the first thing that they're used for is isolation. Okay, so between here and here, this is one circuit over here, and the purpose of this circuit is to make a magnetic field. And we just saw, I showed you ones that had 12 VAC, 24 VAC, 24 VDC, 120 VAC, to 40 VAC. I showed you all different types of voltage ratings here that would give you a magnetic field. You got to hook them up to the right voltage. Okay, that magnetic field, that does not physically touch the contact over here that's moving. Okay, it's just the magnetism that is pulling this over. So these two are separate from each other. Okay, so if for some reason I got a big spike in voltage over here, I'd get a big surge on this coil, a big magnetic field, and then it might just catch on fire. Well, what happened to the circuit over here? Probably nothing. It probably just slammed this contact shut, and then after this burned out, it just opened up. Okay, whereas if you just had these hardwired, directly to each other, and you didn't have that interaction here, if you gave the voltage on this side, it's just going to power up and burn up the other side of the circuit. So they're isolated from each other because between a magnetic field, they do not touch each other. Another thing that it might be used for is an interlock, okay, or sometimes a crosstalk. And what that is you might have a machine 1 over here. This machine over here might be doing an operation, and when it gets done, it turns on the relay. It turns on the magnetic field, okay? And then this over here might be a second machine, and this contact right here might run into the second machine. And when this switch closes, it's almost like somebody pushed a button, and the second machine would start doing its work and do whatever it wanted. Okay, and then when this machine got done, it could do the opposite. It could turn on its own relay over here, and it could switch a contact on this machine. So they could kind of talk back and forth based on a relay. Like, I'm done. Okay, you start. Okay, I'm done now. Now you start. So it would work like that. The big thing that we're going to use these for is to switch a large load. Okay, so switch a large load. So what does that mean? That's primarily what these relays are very useful for. So on this over here, I could use one of these voltages to turn on this magnetic field, and it isn't going to take much current. The current coming through here to make the magnetic field is going to be small, okay? But I get a magnetic field, and then I close this contact, or in this case, you know, I showed you three or four sets of contacts, right, would get closed over here. But these contacts can handle heavy loads. You know, you might have a contactor that can handle 10, 20, 30, 100, 200 amps over here. So the current that's going to be able to flow through here is very large. Whereas over here, we might just have, you know, we might have a 0.5 amp magnetic field turning on a circuit that switches on 200 amps. So the wires on this side would be very small, and the wires running into the switch on this side could be massive, you know, 1/4 inch in diameter or something like that, switching something very big. So that's really what we use it for. It can be used for memory. So we've already shown a memory circuit where we turn on the control relay, right? We turn on the control relay with some type of a push button here. And then what we did was we put in a memory location here. So the control relay here, and then this holds right here. Okay, so the memory and the logic, that's a very good use of a relay. And so finally, the thing that we could use it for would be using it for control of a power circuit. Okay, control of power circuit. And what that is, the control of a power circuit, is related to this, that we can have this, we can do some memory here, and we can have this control relay come on, and it can switch very heavy loads on a power, turn on huge motors and such, huge pieces of equipment. But at the same time, we can put our safety circuit in here on this. That's, once again, this is drawing very small amount of amperage. But when this gets shut down, we can shut down this side of the circuit that can be covering, that can be transmitting very high current. Okay, so that's the control of that. So there's a couple of relay basics, and we will be covering lots of relays in this course.